Okay, so continuing with our proofs for our theorems for AAA, SAS, and SSS triangle similarity theorems. So we have here for corollary number 1. Right triangle TAY when AG as the altitude to the hypotenuse. So you want to prove that TA, okay, so TA over AG is equal to AG over GY. So by using theorem 1 as stated above, it can be said that triangle TAG and AGY are similar to each other. Since the corresponding sides of similar triangles are proportional, therefore we can say that TA all over AG is equal to AG all over GY. So that was corollary 1 right here. Okay, so this one. The length of the altitude of the hypotenuse of a right triangle is the geometric mean of the lengths of the segments of the hypotenuse. Okay, so how can that be the geometric mean? So that can be like A all over B is equal to B all over C. Therefore, AG is going to be equal to the square root of the product of TA multiplied by GY. Okay, so this is the geometric mean of AG. So that's how we will get the value of the altitude. So for corollary number 2, right triangle WRP and RQ as the altitude of the hypotenuse. We have here WQ all over WR is equal to WR all over WP. And QP all over RP is equal to RP all over WP. So again, by using theorem 1, it can be said that triangles WRQ and WPR, okay, are similar to each other. Since the corresponding sides of similar triangles are proportional, hence it can be said that WQ all over WR is equal to WR all over WP. In the same manner, we have triangle RPQ is similar to triangle WPR, and hence we have QP all over RP is equal to RP all over WP. And again, corollary 2, it says here, okay, let's go back to corollary number 2. It says here that the altitude of a right triangle separates the hypotenuse so that the length of each leg of the triangle is the geometric mean of the length of the adjacent hypotenuse segment and the length of the hypotenuse. Okay, so let's try to check that here. So we have here WQ. Okay, so WQ is equal to, okay, so I'm sorry, WQ over WR is equal to WR all over WP. So we have here the geometric mean of WR, okay, so the adjacent, okay, so the hypotenuse is equal to the square root of WQ multiplied to WP. Okay, so that's what the second corollary says. And also, we can say here we have your QP all over RP. Okay, QP all over RP is equal to RP all over WP. So we have here RP. So that must mean that RP is equal to the square root of QP multiplied to WP. Okay, so that's the second corollary for you. Okay, so let's try to apply the corollaries 1 and 2 on this problem. Peak wants to build her own solar panel in the shape of a right triangle. Given below is the blueprint of her triangle's triangular solar panel. Find the values of A and B. So first we have to write the proportion. Okay, so to find the value of A, we need to find the, okay, we need to use the, we need to find this one. Find the value of A. So this is the geometric mean. Okay, so it's the geometric mean of, okay, the sides that we have here. So we can say that 4 over A is going to be equal to, okay, so it's going to be equal to A all over 4 plus 8. So we're going to try to find A, which is the geometric mean. And then for letter B, we're going to use the first corollary to find the value of B. So that's going to give us, okay, so using corollary 1, okay, we can say that 4 over B is equal to B over 8. So now solving for the geometric mean of these sides, okay, so that's going to give us A squared, okay, and of course, since we know that the geometric mean is just going to be equal to A is equal to the square root of 4. Okay, so this becomes 12, ano? So 4 times 12. So this one is going to be b is equal to 4 times 8. Okay, so this is going to be equal to, okay, so this will give you square root of 48, and this one is going to give you square root of 32. Okay, so since we can factor 48 to 16 times 3, so therefore we can say that the value of a is equal to 4 is equal to 4 square root of 3 feet. And letter b, okay, so b is going to be equal to 16 times 2. Okay, so it's going to be square root of 4, square root of 2, okay, 4 square root of 2 feet. Okay, so that's the value of b. And this is the value of a. So a is equal to 4 square root of 3 feet, and b is equal to 4 square root of 2 feet, using the geometric mean. Okay, so for our problem here, we have Aaron is planning to go to Makati Science High School to inquire about the enrollment for senior high school or for grade 11. Right now, he is at point D. He went to Makati High School, okay, to inquire, and also to San Isidro National High School to inquire as well. He determined that MHS and SINHS, okay, that from MHS to SINHS, the distance is 300 meters. And from San Isidro to Makati Science High School, the distance between the two schools is 900 meters. So this is just hypothetical. So this is not true, hypothetical. From San Isidro National High School, he decided to walk straight southward direction, and he arrived at point D. So Aaron is now here. So you want to know the distance of Aaron, okay, from Makati Science High School. We want to know the distance between D and B. Okay, so how do we do that? Since we have here a right triangle, okay, so we have here a right triangle, we can solve for the value of AB using the Pythagorean theorem. Is that right? Okay, so let's try to use the Pythagorean theorem on this one. Okay, so we have here, since we have here AB, okay, AB squared is going to be equal to AC squared plus CB squared, since triangle ACB is a right triangle. To solve first the value of AB, and after solving for the value of AB, we can solve for the value of DB, which is what we want. Okay, so this is going to give us AB squared is equal to 300 squared plus 900 squared. So that's going to give us AB is equal to, okay, 300 times 300 is going to give you 9,000 plus 81,000. Okay, so let's try to use our calculator. Okay, 300 squared plus 900 squared, so that's going to give you 90,000. And the square root of 90,000, okay, so AB squared is equal to 90,000, and therefore AB is equal to 948.68. But we want to get the value of DB, so therefore we're going to use a similar triangle proportion. Okay, so we're going to use proportions in order to solve for this value of DB. Okay, so using corollary number 2, okay, so using corollary number 2 from our right triangle similarity theorems, we can say that DB all over BC, again the geometric mean, is equal to BC all over AB, the one that we solved a while ago. So this becomes DB all over 900 is equal to 900 all over 948.68. Okay, so this is in meters. Okay, so AB is equal to 948.68 meters. So this will give us DB. Okay, so 948.68 dB is equal to 81,000. Okay, so 900 squared, so that's going to give you 810,000. Okay, so if we divide both sides by 948.68, we're going to be left with dB, which is what we want. So 810,000, okay, 810,000 divided by 948.68, the value of AB. So therefore, DB is equal to 853.82 meters. Okay, so therefore, Aaron is 853.82 meters. Okay, so let's write that. Aaron, okay, Aaron is 853.82 meters from Makati Science High School at point D. Okay, so that's the answer for our for our problem that we have here for right triangle similarity. Okay, so that's all for right triangle similarities. Our next lesson is going to be special right triangles.